Hello all and welcome back to the second part of the scan data assignment or exercise. In the second part, we're going to focus on the front surface right here and how we can best use the cross-section tool to create some really nice curves. So I'll begin with trying to create a couple of nice rail curves along this surface right here. And to do that, I'm going to need some Z sections. So I pick the scan data and I apply the Z scan sections and set the distance to only 2 millimeters. That gives me a variety of choices. I can pick one of these to try and fit. Let's turn off the shading and we'll start by fitting a 2-degree curve to one of the lowest cross sections right here. We could turn on the diagnostic shading like this to see how far along this curve I dare to go. And I snap my curve onto this cross section right here. So I don't want to go out here where the radius has begun already. So I'll stop about here. And similar to what we did in the first part with the square surface, I'll now try and approximate the location of the second point of this curve, which will be, I would say, around here somewhere. And just as we used symmetric modeling for the surface in part 1, we can do it also for curves, and it works in a similar way. So we go to Object Edit and hit Symmetric Modeling, and we get that little plane symbol there indicating that this is a symmetrical curve. So whatever I do on this side will also happen on this side. And what we'll try to do now is to pull this CV in the X direction. So I just go X for move, hit the left mouse button and pull it forward and try to fit it as closely to the cross section as I possibly can. That was a little too far, wasn't it? So something like that maybe. And in order to check how close we are, we could use a locator, deviation, curve to curve. So we hit the curve right there, and also the cross section curve, and we get the analysis, which tells us we're about 1/10 away from the scan data, which is plenty enough for us. I'll go ahead and make another one, turn on the diagnostic shading again, and 2x2 or 2-degree curve somewhere in this area. And I think we can go for maybe that one. Snap it on to the cross section. Don't go too far out. So let's stop about there. And 1, 2, 3, 4, 5 from that one, and try and find the spot on the other side. So 1, 2, 3, 4, 5, and snap it onto this cross section right here. Again, we want to be symmetric, so we go to Object, Edit, Symmetric Modeling, and turn off the diagnostic shading. Pick the middle CV and move it in the X direction with the left mouse button, and try to fit it onto the scan data. That looks pretty good. And we can check that with the locator as well. A curve-to-curve deviation. Hit the curve right there, and also the cross section right there. And we are within, well, nearly within 1/10 of a millimeter away. Now, in order to create the generation curve, I'm going to run a bi-rail between these two. And to create the generation curve, I want to make a curve that is normal to either that curve or that curve, rather than parallel to the XZ plane. In order to do so, I can use the cross-section tool once more, but this time I'm going to create a new one, and it's going to be a radial cross-section. So a radial group, here I can set the number of intersection planes. If I go to 31, for instance, and I hit the curve I just created up here, I get a number of normal planes along this curve that will intersect my scan data if I choose to do so. I want to reduce the number of planes because I really just want one plane at the end of this curve, and perhaps also at the symmetry plane. So if I reduce the number to 3, I will get one plane here, one here, and a symmetric one over there. And I go pick object, I pick the scan data, and I apply my created cross sections. And what you can see now are 3 cross sections distributed along this curve, and they all meet up in one point right here. So this would probably form a pretty good circle. Now, the next thing I want to do is to trim. No, that one is, of course, right there. I want to trim this curve to stop at this cross section right here. And I can do that by just choosing extend merge on this curve, which is symmetric. So anything I do here will also be reflected over here, as you can see. So I want to get the end of this curve as close to this cross section as possible. I move it here and I zoom in really closely. And that will take me about there. Now I want to create a curve along this stretch of the cross section here. So just this stretch here. So again, I will use my 2-degree curve, snap it onto the curve I created here, and put the endpoint along or at the end of this curve right here. And so far I only have a straight line, and I now want to fit this curve to this segment right here from the cross section. In order to do so and to hit and work in the correct plane with this curve, I am going to pick the middle CV right here and move it onto this cross section here. I snap it on there like that. This will ensure that I work in the same plane as the cross section. I can now use the Xform CV tool and move it normally to the curve to bring it up to where I want it. Let's just increase or decrease the mouse sensitivity here. And I can move it in that plane really close to my my cross-section curve right there. And again, we can check that using a locator, curve, hit the curve, and hit the cross-section. And you can see we're within 300ths of a millimeter already. So if I now run my bi-rail, it should come up pretty nicely. Let's see. Surfaces, swept surfaces, rail surface, and we want 2 rail curves and 1 generation curves, and only position for the curves involved. So I want to sweep this curve along this one and that one, just like that. And let's have a look at what we have here. Let's get rid of the curves to begin with. We don't need those anymore, but we can put them in a layer here, this side, and take a look at the surface. What do we have here? A very nice low degree 2x2 surface. Looks nice. Let's check with the deviation map. Let's set that to 0.2, hit the surface, and hit the scan data, the color mapping. So we are well within 0.2 millimeters. Should we go for 0.1 as well? Something is happening here. We could fine-tune this by working with the CVs. Can give it a quick shot and see what that does. And we go normal here. I think we can tweak it a little bit. And there we go, within 0.1 millimeter. So how does this look if we run some diagnosis on it? We can shade it and just look at the highlights. And there should be no surprises here, I don't think. It forms a happy face. You can see another neat kind of shader to use is the ISO-ang, which gives us the color bands. Let's just hit the surface to begin with. And shows no surprises really. What this tells us is that it has an evenly distributed curvature along the surface in both directions. We can compare this to the scan data. If we use the same diagnostic shader on the scan data, well, you can see it's really bumpy and rough, but you can still see that the principle of the reflexes along this surface looks about the same, forming that happy smile that we had on our surface. So it looks fairly okay, I would say. What we want to do now is to perhaps extend the surface slightly up, so we're pretty sure that we can use the surface to create the radius over here once we have this big surface up here. So if we again look at the deviation map, we can now see a clear band where the radius should begin. I should probably bring that up a little bit more with extend merge, just to make sure we have this border right here. For the third part of this exercise, we are going to look at a way to create this surface, side surface right here. So welcome back. Thank you.